Hi everybody and welcome back to Exponent Rules. So this video is just really, we're going to be talking a lot about rules of exponents. And so with that, we're gonna kind of be going through a lot of examples, a lot of rules, but basically I have a table here of all the rules that we're going to talk about, or what we call exponent properties. So we have the product property, the power property, the power to a product, the exponent properties, the zero exponent definition, and then the quotient power property. I'm going to highlight the ones that kind of go together. I do believe that like all the power properties kind of go together, so all of these kind of go together. And so does this one. So I'm just going to highlight them all together. They're different ways of kind of saying the same thing. So just keep that in mind. We're going to start by talking about the product property. And so let's look a little bit more closely at what we're looking at. So if I were to say, for example, if I have the same base, and that's very important, you have to have the same base for all of these and different exponents. What I'm really looking at is, say if I have x squared, that's really looking at x times x. So basically x multiplied twice, or by a factor of 2. And x cubed is really multiplying x 1, 2, 3 times, because the 3 represents how many times I'm multiplying by. So I'm multiplying by x 3 times, or a factor of 3. So then if I start counting how many x I have, 1, 2, 3, 4, 5, the 5, or the number, the total number of really x's that I have is really going to be my new factor, or my new exponent. So really, we're just taking the two exponents and adding them together. So having that in mind, that is where we're coming up with this product property for exponents. I'm really taking a look at what the exponents are, provided that the bases are the same. And the base doesn't change, but what does change is that now I'm adding the two exponents together, and that's really all it is. So if I'm taking a look at my first example, my bases are the same, they're both y. So what I'm really going to be doing is, if you think about it, I'm doing y times y times y times y times y, which is y multiplied 5 times. And then I'm multiplying it by a set of y's. 3, 4, 5, 6. That's 6 times the quantity y. So really, I'm taking a look at the 5 and the 6, and if I were to go ahead and count all of these, I end up with 5 plus 6, which is y to the 11th, because I have 11 x's. So really, I'm just adding the 5 and the 6. So another way of writing this would be y5 to the 5th power plus the 6th power, which is y to the 11th power. And that would be your answer. Okay, so I'm not going to do this every single time. I'm just showing you that it works pretty much for anything as long as it has the same base. Now in the next example, we really have a part A. And part A is saying 2 to the 5th power times 2 to the 9th power. And really, since they have the same base of 2, that's going to stay the same. And I'm really taking the 5 and adding the 9. So 2 to the 14th power would be my answer. Now for part B, it's saying 3 times 3 to the 4th. Well, if I don't have an exponent clearly listed up here, we assume that that exponent is 1. So really I'm doing 3, 1 plus 4, which is 3 to the 5th power. And that's where that's coming from. Now, I've only been multiplying 2 things at a time, but I can multiply more than 2 things at a time. So for example, I can take the d to the 4th times d to the 5th times d to the 2nd, and provided that all of these are the exact same base, which they are, I could do d, and that would be 4 plus 5 plus 2, and do all of that first. So d to the 5 and 4 is 9, 9 plus 2 is 11. So that would end up being d to the 11th power. Okay. All right, so that kind of ends all of the product rule ones. So let's talk about the next one, which is going to be the quotient property for exponents, okay? So very, very similarly, we are looking for things that have the same base. So these, again, only apply to things that have the same base, okay? And I have two different examples here. So once they have the same base, I'm looking at really x to the 5th power, which means it's x multiplied 5 times in the numerator, and x squared, which is really x multiplied twice in the denominator. Then if I were to go ahead and start canceling some things out, which actually we did in the next step there, we're going to realize that how many x's do we have left over? Well, we only have 3 x's left over. So if you're to think about it, I'm really taking that x to the 5th power and I'm subtracting the exponent in the denominator because I'm taking 2 of them away. So that's how I end up with x to the 3rd. Similarly, if we look over here, I have x squared, which is the same thing as saying x multiplied twice, and I have x cubed, which is x multiplied by itself 3 times. And again, I'm starting to cancel some things out, and I'm left with 1 over x. And the 1 is important because if I did not have the 1 that had gone away, I can't have nothing over x. And we do need to say that's not the same thing as saying x, right? So like 1 over x is not the same thing as saying x. So it's really important for us to have that 1 there as what we call a placeholder. So this 1 is what we call a placeholder. It holds the place for there to be some kind of a numerator, okay? Because 1 is not going to affect it. It's just saying that it is smaller than 1. It's a fraction, makes it a fraction, okay? So that's why we end up with 1 over x. Now, here's the official property. So again, notice I have the same bases. We have a and a for all of these, and you're going to end up with an a. Okay, and then I'm looking at my exponents, and really I'm subtracting. Okay, same thing here. The only difference is that in this case, in the second case, in this case, the denominator exponent is larger. So because it's larger, we actually subtract the exponent from the numerator from the denominator. And in this next case, or in this first one, we're saying that the numerator denominator is larger. So that's when we subtract the denominator from the numerator. Okay, so basically you're doing the largest exponent minus the smallest exponent, and you're going to keep the place of the largest exponent. If that makes sense. Okay, so let's do a couple of examples here. So we're going to have x to the 9th power over x to the 7th power. So again, I'm gonna take this a, part A, and I'm really gonna like show you what it would look like. So I have x to the 9th over x to the 7th. And really what I'm saying here, and I'm going to move this a little bit up so my handwriting doesn't suffer. So I have x times x times x 9 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, perfect. And then we're going to have 1, 2, 3, 4, 5, 6, 7 in the denominator because that's what x to the 7th represents. And I'm going to start canceling some stuff out here. Okay, so I have 2x's left over in the denominator. Instead of just doing all of that and crossing everything off, because I have my quotient property of exponents, I can say, well, my larger denominator is in the numerator, so my answer is going to end up being in the numerator. So I'm going to subtract the smaller exponent from the largest exponent, and I end up with x squared. So notice it's the exact same thing. It just took me a whole heck of a lot less time to do. So part B. Part B, we have numbers. That's okay as long as they're the same number. And in this case, they are. I have 3 to the 10th power, and then I have 3 to the 2nd power. So if I were to subtract the smaller exponent from the larger exponent's in the numerator. So I'm going to do 10 minus 2, which is 8. That's a terrible 8. Let me redo that. To the 8th power. And that's your answer. Okay, so notice both of these, we end up with whole numbers because both larger exponents were in the numerator. However, that's not always the case. And I'm going to just change colors here just so that we can keep ourselves organized. So A says we have b to the 8th power over b to the 12th power. And I'm just, again, for the sake of being able to visually understand what's happening. I have 1, 2, 3, 4, 5, 6, 7, 8. Perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wowza. That is definitely not the most efficient way of doing it, which is why we still have this property itself. So notice all my numerators, b's, end up canceling. So I'm left with having to put a placeholder in the numerator. And I have 1, 2, 3, 4 b's. So it would end up being b to the 4th. Now notice, instead of doing all of this, okay, instead of doing all of this part, what I could end up doing is just saying, all right, well, I'm going to have a placeholder in the numerator because I know my larger exponent's in the denominator, so my answer is going to end up being in the denominator. So I'm going to do my larger denominator exponent minus my numerator exponent. And that ends up with 1b to the 4th power, which is the exact same thing. I just can skip all of this and go straight to there. So it's actually less work for me. But you have to understand what's going on. Okay, 7 to the 3rd, 7 to the 5th. Again, you could do all of this stuff, but why do I have to do all that when I know my largest exponent is in the denominator? So I'm going to have a placeholder and do my base, largest exponent minus smallest exponent. So I end up with 1 over 7 to the 2nd power. Okay. All right. Last set of examples, and then we are going to move on to the next video just for time's sake. So we have a to the 5th power divided by a to the 9th power. So my largest exponent now is in the denominator. So for a, I'm going to switch colors again. So for a, we have a to the 5th over a to the 9th. My largest exponent's in the denominator, so I'm going to have a placeholder in the numerator, a to the 9th minus 5, and that's 1 over a to the 4th. Okay. B. We have x to the 11th power over x to the 7th power. So 11 is my largest exponent because 11 is bigger than 7. So I know my answer is going to end up being in the numerator. And I'm going to do my largest exponent minus my smallest exponent in the numerator. And then that's going to end up being x to the 4th power. And that's really all there is to it. These are two very, very, very big properties that we definitely need to know. Now the other ones are big as well, and we will go over them in the next video.